Hello, everybody. Welcome to Panel 5, Session 4 on the last day of our ECEE Industry Efficiency Conference. I'm Rod Janssen from Energy and Demand, and I'd never said this before, but Energy and Demand is actually one of the sponsors of this conference. So please go to our website. This would be great. Our session is on increasing demand for financial services, but I want to just say a little word after our session, which ends in an hour and a half. Half an hour later, we're actually having a networking session where you can bring a beer or a glass of wine, glass of water, or just show up, period. What we want to do is have a little talk on the Energy Efficiency Directive because the Commission will be revising it as part of the whole European Green Deal. And there's a consultation underway, and we have to provide our input to that consultation by the 21st, which is Monday. So if you have some views on it, please attend. If you can't attend and you still have some views on it, send it to me or to Diana or to Rachel, and we'll make sure that it gets to Niels Borg, because we really want to give as robust a view on our views of the Energy Efficiency Directive. And as you know, on industry, there's the mandatory energy audits, the promotion of energy management systems, there's the support for SMEs, which there's the energy efficiency obligations. So there's quite a few areas where industry comes into it. Anyway, we should get going. We have the first speaker talking about risk mitigation for industrial excess heat recovery projects. We have Elsa Chony, who has the most creative title I've ever heard for anybody. She is an excess heat recovery engineer from ADEME, the Agency of Ecological Transition here in France. Elsa, please.
Okay, can you hear me?
Yes.
Yes, you can. Okay, wonderful. Good afternoon, everyone. So I'm Elsa Chony. I'm working at the ADEME, the French Public Ecological Transition Agency. We have several roles, including advising the government on environmental matters, and also helping the project leaders to build the projects and to finance them. I personally work in the industry department and mainly on excess heat recovery projects. And I'm here today to talk to you about the necessary risk mitigation of these projects and the support they seem to need to success. Next slide, please. Thank you. We talk a lot about renewable energies to decarbonize our activities. But before trying to produce new energy and more, there is a huge potential of energy already waiting for us just to be used. Just a reminder, excess heat is the heat produced by a process, but it's not the main goal of this process, and it remains most of the time unused. For example, the smoke of an oven in a glassmaker factory is really hot, and most of the time it's not used, and it's basically released in the air. I'll be talking a lot about recovery, about heat recovery on process, mainly because I'm in the industry department, but there is also a huge potential in the tertiary sector. For example, we see more and more data center using their excess heat. The advantage of such an energy are numerous. I'll only talk about a few of them. The first one, it is that it's already paid, so as it is necessary to the process. So when you talk to an industrial actor, it's really useful as an advantage. Secondly, the potential is huge. We conducted a study in 2016 to estimate the potential of excess heat recovery in France, and the results showed that more than 109 terawatt-hour was available in France without considering any constraints on temperature level or the proximity with district heating network. After that, excess heat recovery can also be seen as energy efficiency, which is the first step of a logical energy management strategy. So it can, as a consequence, increase the competitiveness of industrial actors by reducing their costs. And finally, this is an energy which is cheap to recover and most of the time leads to projects that are economically viable, which is a good point. And despite a significant support from Europe and from France, what we can observe is that there is only a few projects that emerge. So we tried to understand why and to analyze, firstly, the sources of excess heat. As you can see on the diagram on the right, the industrial sectors presenting potential are numerous. It's not concentrated on only a few of them. So it's difficult to talk about heat recovery in general, as all sectors have their own process, for example, and specificities. Next slide, please. I don't see the next one. Raquel?
The slides change. Just keep talking.
Okay. To quote only a few barriers, there's also one which is the multiplicity of stakeholders involved in a project. The one who consumes the energy, the one who produces it, the one who finances the project, the local authority, and sometimes in each role there are several actors. So to make everybody sit around the table and conclude a deal is not an easy task. Then finding financial support also appears to be real tough. Difficulties, what we observe difficulties, mainly due to information asymmetry between the financial actors and the project leaders, which leads to a lack of trust between the actors. And finally, energy production is not the activity of the producer most of the time. The glass maker makes glass, not energy. So it's delicate for him to be involved in a project, in complex projects, disconnected from his main reality, I must say. So as the difficulties encountered by those projects are not only technical or financial, we decided to conduct a study to design and implement an empirical risk analysis approach. Next slide, please. In order to tackle those risks, especially from the financing institution viewpoint, the ADEME conducted a study in order to obtain a comprehensive overview of standard risks that are encountered throughout the life cycle of a heat recovery project, from the idea to the financial consumption of heat. The objectives were first to define those risks, to characterize them, to identify the possible causes, the existing mitigation measures, and the possible new ones we could settle. We based the study on 10 real and very different projects, some success, some failures, and some not even finished, just to have a large panel and representative panel. And we identified several types of risks. The first one is technical ones. For example, how am I sure that the factory will be there in 10 years when I'll still need heat? After that, organizational risks. As I told you, it's hard to put everyone around the table to conclude a deal. The financial or economical risks. For example, to fail to achieve profitability because of, for example, the evolution of energy prices on the market, as we can see today, because of the sanitary crisis mainly. Or an evolution in the situation, for example, as I told you, the industrial leaving, or its production decreasing, or the consumption of the city increasing. So there are a lot of fluctuations that can influence the projects. and other legal and operational risks. Next slide, please. So the study led to this matrix. Will arrive, I'm sure. In the column, you can see the 10 different projects I talked to you about, and in the lines, the risks that we identified with the categories. I'm sorry, I realized the categories are still in French, but as it was a picture and not a table, wasn't able to change it. So most of them are already listed on the previous slides. So just to translate quickly, development risks, temporary availability, permanent availability, demand, tariff, selling, financing, and others. So as you can see, only a dozen of categories were necessary to characterize all the 10 projects, which is good news, because the easiest it is to identify the risks, the easiest it is to mitigate, the easier it is to mitigate them. And as you can see, not all the projects encountered the same risks at the same time, and especially not at the same intensity. So this heterogeneity leads to a necessity of haute couture mitigation measures. You can answer to those multiple risks with only one big mitigation measure. After that study, which ended in December, we chose to complete this matrix by characterizing more precisely the risks and to allocate to each one of them one or several mitigation measures for prevention or protection of the risks. Next slide, please. And we are currently here. So this is the last version of the matrix. We were a bit delayed in the study because of the sanitary context. So, and this matrix, I translated it. I didn't see it yet. Yeah, wonderful. Oh, went too far. The first three columns of the matrix are the characterization of the risks. So the nature, the subcategory, and the risk itself. For example, if I take the third line, if we take a financial risk, for example, the terms of the contracts weren't respected. For example, because of a variation in the energy prices. If we go to the next slide, still on the third line, you can see that before the projects, it could have been prevented by conducting a sensitivity analysis, and it could have been, well, the projects could have been protected by including in the contracts some assurances or penalties, for example, or indexation on energy market prices. So there are a lot of mitigation measures possible, and all are still not listed there. Next slide, please. So I should be presenting you a finished tool, which is not the case, I'm sorry. It should be operational by now. We want to include this risks database in a tool to help the project leaders to characterize their project and to identify the risks they could encounter depending on the type of the project and the intensity, the risk intensity they could encounter. And we would like to include that tool in our feasibility studies to help the project leader to anticipate all the risks. And in our training programs, we have two main, one with the for the financial actors and one for the technical actors. And of course, this tool will be challenged and updated regularly just to remain accurate. So I hope I was clear. I hope I'm right on time. and I'm here for question if you need.
Elsa, thank you very much. We're going to take all the questions towards the end, so we'll get into that. That's a very interesting tool you've got. And also, I mentioned the Energy Efficiency Directive before. I mean, the one thing that it is also talking about is the use or the promotion of using waste heat. And so trying to find ways of doing it. So you're onto the right thing. In fact, we may get into you expanding on some ideas that you may have for the Energy Efficiency Directive. So just think about that while you're listening to the other presentations. Next, I'd like to bring Thomas Motmans. He's a sustainable energy financial specialist from the Basel Agency for Sustainable Energy. And he's going to be talking about cooling. And I think this is, especially as we're dealing with climate change and a warmer climate, we're all thinking more about cooling. And this is going to be a much more global than just on Europe. In fact, not on Europe at all, but we're really looking forward to this. Thomas, over to you, please.
Hello, everyone. Thank you very much for being here. I'm trying to put my camera, but I believe I already have control of this slide. So maybe Rachel, you can just give it back to me so that I can activate the camera. In any case, in the meantime, thank you very much for taking the time to listen to our experience with this innovative business model. Cooling as a service, and thank you to Diana and Rod for moderating this session and for eceee for setting up this great virtual event. I represent BASE, a Swiss not-for-profit foundation and a specialized partner of United Nations Environment, founded in 2001. We design, develop, and implement innovative business models, financing structures, and risk mitigation mechanisms to incentivize investments in energy efficiency, renewable energy, and climate change solutions. And during this presentation, I would like to give insights into a disrupting business model that has a potential to massively increase efficiency in the industrial sector. And during the past 3 years, we have worked on advancing the implementation of this model in the cooling sector, by which I refer to air conditioning and refrigeration. And this serves really as an illustration because we can also replicate this model in many other energy efficient technologies. Why cooling? Scaling up the adoption of clean cooling is urgent both to reduce energy consumption. Air conditioning alone consumes 10% of the world's electricity today, and this is set to triple by 2050, and also to reduce the impact on climate change of refrigerants currently in use by these systems. The cooling industry is also a large business opportunity because according to the IEA, International Energy Agency, $6.9 trillion will be invested in air conditioning alone over the next 30 years, and this is equivalent to $230 billion per year. So for most cooling technologies, like is the case for other types of equipment, the main component contributing to the life cycle cost of that equipment is actually electricity consumption and maintenance, as you can see in this diagram. The initial investment is only a small fraction. So in other words, if we want to reduce the total cost of ownership of the cooling system, it is done best by installing, first of all, the most efficient system in the first place, and also by optimizing the maintenance of the system, as well as by applying what we call system thinking, which means adding components, in this case, for example, thermal energy storage or passive cooling, to make the whole system more efficient and effective. Still, market barriers and also misaligned incentives result in cooling users still investing in technologies that require lower upfront investments, although they result in higher operating costs. And some of the key factors that we have identified are, first, users are sensitive to purchase price of that equipment. But that's not all. There's also the fact that users, so when I say users, I mean cooling users, they tend to lack trust in the performance of the equipment or whether the savings will actually be sufficient to justify the investment. Third, users prefer to invest in their core business. So Elsa mentioned this before, a glass maker focuses on making glass, not energy. It's the case for most industries. Cooling or air conditioning, refrigeration is not their core business. And finally, cooling users often do not have the expertise for adequate maintenance, And in traditional business models, the solution provider does not necessarily have the incentive to offer optimal preventative maintenance because they're not the ones paying for the cost to actually operate the system. And that's why servitization, or moving from selling products to selling services, from a transaction model to a subscription model, aims at overcoming these barriers. And for cooling, we call it cooling as a service. And by this, I mean a model in which the user actually pays per unit of cooling consumed and does not need to invest in or operate that system. And here we can see a diagram which shows that product as a service models are really not new. They're actually growing rapidly across industries. And to name only a few, you probably all know the Xerox model, who sell copies rather than selling actual copy machines. We have Signify with Philips offering hours of lighting to the Schiphol airport in Amsterdam instead of the airport purchasing the actual light bulbs. And in the solar sector, it are really power purchase agreements, PPAs, that have enabled the rapid uptake of photovoltaics. And this has been by enabling customers to essentially purchase kilowatt hours of solar energy instead of having to invest in the solar panels. And this essentially eliminated the performance risk perceived by these customers. In the cooling sector, we're now really at the brink of such a revolution, and servitization is attracting a lot of attention from many different actors across regions, because the model really has a potential to be a true game changer for the cooling industry, making more efficient technologies more competitive than the cheaper, less efficient technologies. So we hope to see this increasing. Last year, we presented the model to what's called the Global Innovation Lab for Climate Finance, which is a highly reputable group of institutions and investors in government, the private sector, development finance, philanthropy, who essentially endorsed CAS as one of the most innovative, actionable, and scalable financial instruments of 2019 among more than 250 other instruments. And we published a paper with them, which you can actually find on the Global Innovation Lab website. So how does the model work? It's quite simple. Customers pay the cooling service per unit of cooling consumed instead of purchasing the actual asset and then managing that asset. So the technology provider is the one owning the cooling system, maintaining it, and covering all operating costs, including electricity. This positions the solution provider as the decision maker on the technology used to deliver the cooling. And that decision will be based on a long-term vision rather than on a short-term upfront investment consideration. And also the provider has the incentive to offer optimal preventive maintenance to maximize the operating efficiency, because he's the one paying for that cost now, to reduce unplanned breakdowns and downtime, because if the system is not operating, there's no payment coming, and to avoid more expensive corrective maintenance, which also will be paid by essentially the provider. And the model is also really a strategic response to a circular economy, because it incentives the design of cooling solutions for long-term use, for instance, through modular designs. So the model has key advantages for the main stakeholders, which are in this case cooling users, technology providers, and investors. For users, it's quite clear. They do not need to invest to purchase any asset. They are not exposed to any kind of performance risk of that equipment anymore, and they can focus on the core business by fully outsourcing the service. For technology providers, it is an opportunity to create additional value for customers by fully deploying the potential of new technology, which might have a lot of control and digitalization capabilities. The model also generates predictable and continuous and additional revenue streams throughout the product life cycle, because they're based on long-term agreements. And for investors, so many have actually green financing available and are actually looking for projects to allocate these funds to. And cooling as a service is a very effective vehicle to generate the pipeline for investors to create their green portfolios. And cooling as a service also enables financiers to invest in assets generating cash flows. I think someone is still unmuted, but I'll just go back. There are different possible funding structures to include the investors in the model, to actually scale up the model and recapitalize those providers who are offering the service. And these include forms of asset-backed finance and project finance, Although today I unfortunately don't have the time to go into detail in these, and then maybe I'm happy to share you some more information after the presentation or during the Q&A. During what we have been doing through the CAS initiative has been a couple of things. So there are a couple of components, and the first one has been the development of tools to enable the model, such as pooling as a service contracts, pricing models, financial structures to monetize the CAS projects. And these are all available open source on the CAS website. So when I say CAS website, I mean the website of the Cooling as a Service initiative, which we have launched in 2018 as base, together with the Kigali Cooling Efficiency Program, KSEP. And the aim of this initiative is really to stimulate the market to adopt the model. Second, so after the tools, we are working with technology providers and investment funds around the world to test the model. We have launched earlier this year what we call the Cooling as a Service Incubator, and we work on projects from various sectors, ranging from commercial and industrial air conditioning and retail refrigeration to small-scale cold storage for vaccine and agricultural cold chains. On this roadmap, you can see where the model is currently being implemented. We're supporting providers in the Caribbean, Mexico, Costa Rica, Argentina, Nigeria, Kenya, South Africa, and India to implement the model. And we're working closely with partners who have been implementing the model already in Colombia, Singapore, and India. Europe is not a focus within this specific project, but we are happy to announce actually that we have started a new project this year financed by the European Commission's H2020 program, focused on the development and deployment of this servitization model for efficient equipment solutions, so beyond cooling, energy efficient equipment, in the Netherlands, Belgium, and Spain. And there's a lot of potential in Europe to scale up this model. Thirdly, we have created partnerships with different actors to establish what we call the Cooling as a Service Alliance, which is growing rapidly and today already includes more than 50 organizations. It includes both market actors, such as global cooling system manufacturers and contractors, as well as investment funds and banks who seek to implement the model, as well as networks like the World Green Building Council, for instance, or ESMAP or the Rocky Mountain Institute, who help to spread the word about this model. And finally, the fourth component is to really spread the word about this model and to build capacity through different events and workshops, webinars, publications. And here we can see a couple of examples of webinars with the International Energy Agency, with the World Green Building Council, and some relevant publications have been written about cooling as a service, and a number are upcoming. You can see a couple of newspapers that have mentioned cooling as a service. We have also published some case studies of cooling as a service on our website. Here, there are two examples of the commercial building Q office implemented by MGM Innova Group, which is an investment fund in Colombia, and the fruit packaging firm AfroPro implementing it in South Africa with energy partners. And we also have quite exciting news, which is that we have essentially launched what we call the CAS price, and we awarded cold hubs with this because they offer cooling under a pay-per-use model to farmers who want to store their crop. And finally, our first matchmaking event took place in South Africa in March, and we are planning a global e-summit on cooling as a service on December 1st to cover in detail many of the technical aspects of the model and to showcase projects. So we hope to see many of you there. So this is it, trying to keep this short, a lot to say, but this is trying to give a small summary. So there's a large potential for cooling as a service in general to accelerate the transition to energy efficient equipment. And so I welcome you to also register to our newsletter or join the e-summit. Thank you very much.
Thomas, thank you very much. This was a very interesting. I have seen some references in The Economist or elsewhere, so it was really good to have this. Let's keep going. And we now have Jens Teubler, senior researcher from the Wuppertal Institute in Germany, talking about financial carbon footprint, calculating the bank's scope 3 emissions of assets and loans. This is an incredibly important topic. And yesterday we were talking a bit about taxonomy and all of the issues that related. We were talking mainly about scope 1 and 2 yesterday, but this is about scope 3 is really important. Jens, over to you, please.
Thank you very much. Good afternoon, everyone. As you can see, I'm talking about banks and financial institutions, but the model I'm going to present is not necessarily restricted to banks. Banks are just a very important actor when it comes to emissions along the value chain. The model itself could be adapted to be used directly for, let's say, an industrial corporation to cover their investments, or more importantly, let's say, the upstream materials they purchase. But let me come back to that in the end. Let's try to swap the slides. Yeah, it works. Okay, sorry. Okay, why I'm talking about banks? Regardless of the high importance that's currently put on policy-wise in terms of UN and EU sustainable finance programs, the EU taxonomy, the most important thing about banks is that they have usually very low direct emissions because they are basically just buildings and a bit of electricity for lights and so on. But they have they are responsible for very high indirect emissions along the value chains by giving out loans, by investing themselves, by shareholdings, bonds, and so on. And they really need tools and a better understanding of these effects to successfully steer their investments and their portfolios, and in part also to activate the actors along the value chain, to give them the means to invest into innovations necessary to transform the industry. So our goal was to quantify those GHG emissions, particular investments, loans, and equities. And I'm talking a lot about loans in this case. The challenges are that very few actors report their carbon footprint, their scope 1, 2, and 3 emissions. 3 emissions, not at all, usually. And especially small and medium-sized enterprises have usually not the means or not the knowledge or the expertise to report their carbon footprint. So there's a lot of money in the game, and they have some or a lot of information about who's the person or who's the company that receives the money, but they do not know what the effects of those investments and loans are. So the project we did was for the GLS Bank in Germany that has been engaged in sustainable banking for over 40 years now. And they wanted to get more and better transparency in their portfolio. They wanted to know more about those effects along the value chain. So they asked us to account for the emissions of green and social bonds, their shareholdings, and so on, but in particular for their loan program, which is mostly flowing into small and medium sized enterprises in Germany. Some of the loans are very small, but altogether it's a lot of money. It's I think almost over 3.5 billion euro. So a lot of money, but stretched along about 13,000 loans. So we had the problem that we had not much data to work with. The loan data does not contain a lot of information you need to account for the emissions. So we used a mix of different models, data sets to come up with solutions. The overall report has not been published yet, unfortunately, due to the pandemic issues, so to speak. But some of the other issues are covered in the conference paper that accompanies this conference, so feel free to look it up. I'm now focusing more about on the loan model, which starts with a multi-regional input-output model that has been scaled to account for the output of economic activities, and that has been accompanied by additional models to account for effects in particular the agricultural side of the economy and, of course, renewable energy production. So on the right side, you see let's say a concept of the model, and it's differentiated into 4 steps. each of these steps come with a lot of issues on themselves and limitate the results of the model. Some to a small degree, some to a high degree, some to a degree we cannot quantify with a high certainty. But it provides a, let's say, robust estimation of GHG effects of economic activities. And in this case, these effects are also matched to the classification of loans as done by the bank itself. So they provided us with a list of different types of loans. They provide their own classification system, and we matched this to the scope 1, 3, 2, and 3 emissions of economic activities, representing each 1 million euro of activity or value added. So some of the issues stem from allocating the scope 1 and 2 and 3 emissions. If you look at how the carbon footprint of a company is calculated, then it's very focused on what can a company control, what doesn't control it, what does it purchase, and what are the connections to the rest of the value chain. But the perspective is the company itself. But we used a input-output model. So the monetary and physical transactions between economies and between the activities within economies. And this is not very easy to match to the scope 1, 2, and 3 definitions. So there's a lot of problems with the model when it comes to that. It's rather easy to account for the direct emissions, the scope 1 emissions of an economic activity, but it becomes more difficult when we talk about, for example, scope 2 emissions, the purchased energy use. Because the carbon footprint guideline would tell you that only the direct emission effects of that purchase of energy is scope 2, but all the upstream emissions of providing that energy, the production of the plants and the grid itself is scope 3. And that's not very easy to differentiate in an input-output model. But if we think we dealt with this issue sufficiently for now, I'm going to talk about how we can adapt this model and improve it in the future. The results itself are presented along the 3 scopes per million euro value added. In the model for all economic activities, we used XU-base as a baseline, and as well as for the loan classes of the bank itself, which comprise about 70 loan classes. Looking at the results, I can show the overall results of the project later if there's still time, but this now only deals with the loan model itself. And you see the overarching groups of loans the bank provides on an annual or basis or even a shorter period. And it ranges from, of course, renewable energies, but covers also education and culture, health and social affairs. So it's not restricted to green projects, but a lot of social projects are provided with financial means as well. On the right side is the resulted calculated footprint. In total, it's higher than the avoided emissions we calculated. One of the reasons for that is that we only accounted for avoided emissions if there's a direct cause effect that we could account for. So there might be some additional effects in the system we did not account for just because the methods are not appropriate enough or not advanced enough to account this on such a, let's say, overall global economic basis. On the right side, you see a small window of the data we generated. I removed the first digit because they did not have time to ask the bank for permission to provide, to show you the full data. But what it says is just different loan categories along those overarching financial areas for loans. And then what it comes up with is emissions for each of the 3 scopes, and of course the total of these three emissions. In the project itself, we then allocated these emissions to the bank, saying for once, because we wanted to avoid double counting of emissions, and secondly, it's an open question for what type of emissions the bank is actually responsible for and for what emissions not. Because we're talking about, in some cases, about the scope 3 emissions of scope 3 emissions, so second order effects, and we wanted to avoid this when reporting the overall results. But in the final report, as well as the conference paper, you also see like a theoretical value for the emissions that are generated globally, and what it means in regard to the emissions that were allocated to the bank. Our model can be applied to loan portfolios of any kind, of course. It can, but it can also be applied to economy activity-based scope 3 emissions calculations. So it could be used for a small industrial company that produces one particular product, or is not that large, has not the means to come up with scope 3 emissions. We could provide the means to robustly estimate the emissions from investments, purchased materials, and so on. The strength of the model is that it applies a cause effect of economic output rather than state of economy. What I mean with that is that it is not just cutting down the global emissions in different sectors, but it shows what happens if you put money into the system and what emissions come with that. In that activity itself, but also along all the other actors that are connected to that activity. The limitations stem from the database itself. Input-output tables are very rough, highly aggregated. They are focused on industries, so they do not cover some activities that might be of interest for actual and future trends. Let's say digital services or just purely organic farming are not covered by the tables itself, so you have to come up with solutions for that. The matching process to any type of classification systems comes with issues as well. Some of them are severe, others are, let's say, okay to use. The double counting cannot be solved using the model alone, so there needs to be some research to come up with solutions that avoids that double counting, or that at least shows how highly the risk is that emissions were double counted in one way or another. That applies in particular to scopes 2 emissions when energy producers and energy consumers are in the same portfolio, and one might purchase energy from the other. And the last limitation is that this model still does not account for actual investments. What I mean is, if a manufacturer receives a loan of 1 million euro, and he buys machines for that, the actual emissions take place somewhere else. Well, in the area where the machines that are purchased are actually manufactured. And this is something we think about a lot and try to come up with solutions. And one of the solutions is to put an additional satellite to the model that classifies investments along those emissions relevant activities. Our outlook, I think I'm reaching the end of the time. We want to validate the results using commercially available data. A lot of large companies already report their carbon footprint, especially scope 1 and 2. There are a lot of GRI reports that can be looked at. And then we can sample and we can account for country specifics and industry specific results to try to match our steps iteratively to come up with more robust results depending on the relevance of the activity. We want to also generate additional models that help to disaggregate the rough input-output tables, in particular for buildings, where we see that it's just one large construction activity, but we want to know more about how does, let's say, energetic refurbishment work in regard to just building new buildings, and how does, let's say, zero energy buildings take place, and what emissions come with the production of those. So we also hope that we can add some new indicators. The basis is there for that, just the work has to be done. We could introduce, let's say, raw material consumption indicators. We could probably also add water-related indicators, and we hope that we can achieve that in the future as well, pending funding and the time resources that are needed for that. Thank you very much.
Jens, thank you very much. That was really very interesting. For the audience, we were waiting for a fourth speaker, but he's coming in from California, and he's hopefully having a cup of coffee right now, but he will join us in a few minutes. Meanwhile, we'll have a little question and answer period right now to get things started. First of all, the first question is to Elsa. How do you measure the risk intensity? Could you give us some indication of how this is done?
Okay, can you hear me now?
Yep.
Yes, we can. Okay, so we are not working alone on this study. We are being helped by an engineering consultant firm, Greenflex. So they are currently trying to elaborate the tool. As I told you, we were kind of delayed. So unfortunately, we are only still working on the matrix, the databases of risks. So I didn't get really involved in the tool itself, but I think that it mostly depends on the type of project you're considering. For example, depending on the sector of the industrial factory you are taking the heat in, it depends on is this sector in difficulties currently? So is there risks that it can be moved, that the factory itself can be moved? So I think it depends more on the project itself. So I don't have any general rules I could provide you now, but in the next months you can contact me and we can talk about it.
I'm sure somebody will, no question. But who would be the main user of this tool? Uh-oh, we've lost Elsa.
Every project leaders who need it, all the attendees of our training programs, and I think mainly financial actors who will need to estimate the couple risks and investment to take the decision, to make the decision.
For the training, you mentioned both financial actors and technical actors, but I didn't know if you were talking about financial actors inside a company, like the CFO and that, or if you're talking about financial actors in a bank or something. I didn't know, I wasn't quite sure when you said financial actors, how broad that was.
Both, I think, both I meant.
Okay.
So also within the industry and also banks, for example.
Okay, great, thank you. Thomas, how long have these demonstrations been being implemented? I think you said how long are things going? And also, so another question was, why didn't you start in Europe? I mean, we're at a European conference. We have to ask that, you know.
Thank you. Very good questions, and apologies for not having turned on the camera before. I think now I can show my face. So the pilot projects. So there's a different type. There are different types of pilot projects. Some are projects that have been implemented as early as 2013. We know some projects that have been operating since then in Singapore and in India by a company called Care in Singapore, who's essentially offering air conditioning as a service to their customers. So since quite a while, so a lot of data has been collected, and this has also enabled them to now use what we call a portfolio approach, which means you're not actually basing the calculations on specific projects, but rather on a portfolio of projects. So it's excellent to also mitigate and redistribute and diversify risks. Other companies, so we know of a couple of companies who have already been doing this for a couple of years. So CARE in Singapore, MGM Innova in Colombia since 2017, and Energy Partners in South Africa since about 2015 as well. And we have this year started working on what we call the Cooling as a Service incubator. And through this incubator, we are working with approximately 10 companies in 10 different countries, and they are right now starting to implement the model. So they have now the tools ready, the pricing models, the partnerships. So these are projects that are not yet constructed. So we expect many of these to be implemented in 2021 or even late 2020. So
but is there any incentive in this whole service aspect to improve the technology, to actually be innovative new technologies that there's going to be big breakthroughs?
Yeah, this is a very good question, and I guess we're skipping the European question, but I can go back to it later. The innovation in technology is really furthered by this model because now the technology with cooling as a service or with any type of servitization model, the technology provider is the one that takes the decision on which technology will be implemented, because the technology provider is selling the outcome or the output of that system. So it doesn't matter anymore to the customer which equipment that is, as long as it delivers the service that is required. So this means that if there is technological innovation that enables, for instance, to reduce operating costs to deliver the service, or if there are additional components that can be added to the system, then the technology provider does not need anymore to convince the customer that the customer should purchase that new innovation, because now the provider is the one owning the technology and just has to convince himself that it makes sense.
But I mean, I have to ask Jens, I mean, in terms of if it doesn't matter what the technology is, what does this mean to scope 2 or scope 3 emissions? Jens, do you have an idea about that?
Yeah, I mean, it doesn't matter in this. So the good thing is emissions are highly correlated with energy consumption, right? And energy consumption is highly correlated with operating costs. So that means if the provider wants to reduce operating costs, he needs to reduce energy consumption, which automatically reduces also CO2 emissions. In the case of indirect or direct emissions, for instance, with refrigerants or cooling system use also refrigerants, which might not necessarily have an impact in the energy consumption and the actual costs. But since providers are now the ones owning the system for longer time, they have the incentive to make sure that technology will not be obsolete within 5 or 10 years, maybe due to policies or other regulations. So there's also a direct incentive to make sure that technologies put into the market now with this model are already the latest technologies, to make sure they do not need to be removed from the market within 5 or 10 years.
Jens, do you have a view?
Yeah, as Thomas already said, almost all emissions stem from the use phase of the products. And apart from, let's say, leaking of certain cooling fluids, I don't think that emission-wise, in terms of carbon footprint, that the production cycle is very important. Okay. But it could become important for other indicators regarding, depending on what type of materials are used and what type of processes are used. This is something one can look at, but I don't think that when looking at the overall energy use, and that's the large issue with cooling systems, that this is the first priority I would look at.
And maybe also to complement, thank you a lot, Jens. What servitization enables as well is really improving, for instance, modularity of equipment, so that less new material has to be used to produce additional new equipment, and also to improve the recyclability of those components that might not be able to be reused, because now the provider can generate additional value from these components.
Now, where's the highest potential for use of this service? Is it in commercial buildings? Is it schools, hospitals, hotels, shopping centers? It's not for me in my home, obviously, okay? But I must say, in Paris last summer, well, in July and August, there was panic shopping for air conditioners in all of the appliance shops, the most inefficient equipment people were buying because it was 35, 39 degrees. And so there was a ridiculous spike in energy consumption. Anyway, that's a different subject, okay? But I just wondered where the highest potential for this service is.
Absolutely. So as you pin it down very well, it's mainly currently, we see it as a big potential for commercial and industrial sectors. So we've been working on projects which range from airports to hospitals to office buildings, malls, cinemas, hotels, restaurants, etc., but also residential buildings, but which might be maybe not one home, but a whole building. And the interesting component there is that you can sign, the provider can sign a cooling as a service contract with the building manager or owner, and that building manager or owner can include the cooling as a service in the rent. So that means that the risk is also diversified to some extent, because each user of the building is paying a portion of that. And there can be a fixed component for the common areas, so per square meter, and then a variable portion for the consumption.
Okay.
So it's really those, and also other areas are retail, food, supermarkets, for instance, and food production and manufacturing for cooling as well.
Jens, is the German GLS bank the only bank interested in this kind of information? Do other banks have scope 3 emissions of assets and loans? I mean, like, what makes GLS special? Yeah?
Well, some other banks reported as well. And we looked at first, when we started with the project, at the standards compiled by the Partnership for Carbon Accounting Financials that comprises about 60 banks all over the world. And these guys and women think about a lot about how to account for the emissions along the investment route of a bank. So they are the only one. And we also present one example from Toyota's bank in our paper, where they used mostly primary data and more a bottom-up approach to come up with the emissions. Something we would have liked to do as well, but we lacked the data because we didn't have it just. So we needed to come up with a more complex model. So GLS Bank in that regard is special because they are highly engaged in providing more transparency in everything they do. And they were willing to put, well, it's enough financial resources on the table to employ us to investigate this measure more thoroughly than others might be doing. Regarding the second questions, I will just add the first two steps of the model. The question was whether other sectors are planned to be applied for the model. The first two steps, as they are, can already be used to estimate emissions of any sector that is part of the input-output tables. But what steps needed to be done would be to differentiate the data, to come up with more robust results, to compare these results to primary data and statistics, to get a feeling what results are more certain than others and what the issues are. But we could start now. All we need is, let's say, funding or a suitable project for that.
But you said that there's data problems. You're doing a lot of modeling. How much trust is there in the results? I mean, there's so much uncertainty. I mean, I know this is still in the very early stages. Okay, I understand that.
I'm a modeler, so I'm also always concerned about the reliability of my data, and I'm very critical about that every time, regardless whether it's my model or the model of somebody else. But in my opinion, it's one of the best models out there at the moment that comes up with a first solution to a data issue that has not been solved and will not be solved in the near future. I hope that we get like scope 1 and 2 emissions from every company all over the world in the next 10 years, but I think it's highly unlikely that apart from the big companies, that happens soon.
Okay. A question for Thomas. In Elsa's risk assessment tool, it's for excess heat recovery projects, but would it be interesting for you to improve your product? Could this be a tool that could be of value to you?
Yes, absolutely. So in particular, cooling as a service by itself is just really an example and component, and complementing it with cooling and heating as a service makes absolute sense, especially because just by producing cooling, you do produce heating, and that heating can be used to optimize the service, and it would essentially be an additional service at essentially no cost to the provider. And in that sense, I think tools like what Elsa is preparing could add a lot of value to increase the visibility of the financial and economic benefits of this additional service.
Now, Jens, I'm trying to see if I understand this properly. Say the GLS bank has a loan to an Italian company, and this Italian company exports all of its product to Latin America. Would those transport costs be, or emissions be included?
Yes, but based on the national transactions between those countries, because this is what input-output tables are comprised of. The monetary value of imports and exports between countries and within economies. So it would not reflect that particular company. If it was one company, I would just ask the company for primary data. But if that company is part of 10,000 different loans in a portfolio and the data is not available, then I would put on my model and say, okay, you can estimate this, that these are roughly the scope 1, 2, and 3 emissions of this company or this loan in particular.
How much is the IPCC looking into all of this type of work you're doing?
I think that we are just beginning to understand how important the financial sector overall is for all these issues. We thought probably for a long time that we just need large enough state budgets to get it all going. But we find out that it's not possible without the help of financial institutions. So I think that a lot of discussions currently going on, let's say, for example, regarding the EU taxonomy, getting a lot of heat up, and I think it will be accounted for much better in future IPCC reports. But you have to think about that IPCC scientists are very serious about giving only results out that are absolutely reliable and where they could put a number on how probable is that something happens or not happens. So it will take time to catch up the science with the, let's say, the banks that are already on the get-go and giving out billions of dollars on green and social bonds every year. They just started and ran away with it, and the science tries to catch up with it and tries to distinguish itself from, let's say, the commercial service providers that look more on the criteria-based list whether a particular project is green or not.
Yeah, well, I mean, the IPCC also can only use published data from peer-reviewed papers, academic papers. So they're, by definition, quite conservative in that sense.
Yeah, and at the moment, I would not put it in the peer-reviewed paper.
Lead authors are involved in the IPCC, and they're as frustrated by that themselves because they know that there's much more material out there that could be useful. But anyway, that's that. So, Thomas, what's next? What's going on? I mean, are you getting enough funding? I know, and things like that. I mean, are you doing well? I mean, there's a growing interest in cooling. I understand that. You know?
Thanks for the question. Yeah, so also to respond to your first question about Europe. So we started in other regions of the world, mainly because the funding entity, which is the Kigali Cooling Efficiency Program, which is a foundation based under Climate Works, based in California, supported us, and they have a priority in these regions. The good thing is this has been really kickstarting many initiatives. So for instance, now, as I mentioned briefly, we are starting a new project financed by the European Commission's Age 2020 program, which will last 3 years in Europe, in the Netherlands, Belgium, and Spain, to scale up the implementation of surveyization beyond cooling in these sectors. And we hope that this can continue. So our program lasts until mid next year, and we're hoping to receive some additional funding to continue the good work on cooling specifically.
Great. Thank you very much. Nate, welcome.
Hello, thanks.
I hope you've had a cup of coffee. I know it's very early for you.
It's actually not so early because there's been a misunderstanding. I'm not actually in California right now, so it would be 6 in the morning there. It is 6 in the morning there, but I'm actually not in California. I'm in Stockholm right now, actually. So it's
You're in Stockholm?
3 in the afternoon, yes.
Oh, so. Well, now I'm disappointed. You should have been here an hour ago.
If only my life were so simple. But yeah, so yeah,
okay,
thank you.
Introduce you, and then you can give a presentation. Then we'll have about 10-15 minutes left for all of you, okay? So Nate, and you've also given a paper for ECEE Industry Conference in the past, haven't you?
I have given a couple, yeah.
Yeah, exactly. I've seen your name from past. This is Nate Aden, a senior associate of the WRI, the World Resource Institute Business Center. which obviously must be in California. I thought you were only in Washington, the WRI. Anyway, his talk is going to be on science-based targets for the chemical industry. Nate, over to you.
Great. Thanks, Rod, and thanks to the organizers. There's been some organizational travails here, so glad to be here. I, as Rod mentioned, work with the World Resources Institute, which is a global research organization with about 1,000 staff now. Most of our staff are actually outside of the US at this point. And we are one of the founding partners of the Science-Based Targets Initiative, which is a voluntary platform for companies and financial institutions to set targets for their emissions that are aligned with the Paris Agreement. And we started this initiative back in 2015 after the Paris Agreement. And now it's growing quite quickly. And today I'll just be talking about some things we're doing with chemical companies and the emerging trend of chemical companies setting science-based targets for their emission reductions. So the next slide just gives sort of the basic explanation of what a science-based target is. And so it's an emission reduction target that basically breaks the longer term global pathway down to a shorter term company level target. And they're consistent with achieving net zero in the second half of the century. Actually, we just released some net zero paper publication earlier this week, and we're initiating a net zero standard development process this month that will be a 14-month standard development process. So the next slide gives some more information about the initiative. So the basic purpose of the initiative is to support private sector mitigation ambition. And we do that with a 3-pillar strategy. I don't know if my slides are gone or not, but I can keep speaking.
There's been some gremlin there. Either they've disappeared. Hopefully they'll come back in a minute.
Okay, or I can share my screen if you'd like. It's up to you. This is par for the course for my ECEE experience this year, unfortunately. But shall I share my screen?
Normally Rachel control, yes, we'll try it.
Okay. Let me maximize this here. Of course it switches. Okay, can you see the slides?
Only you.
You only see me, you don't see the slides.
Here we go, here we go, here we go.
Do you see them now?
Apologies, I'm back now, carry on.
Okay, the next slide, please. So yeah, the initiative supports private sector mitigation ambition through a 3-pillar strategy. The first is to reduce barriers to adopting these targets. And so we developed the sector decarbonization approach, which leverages the IEA's ETP scenarios and comes up with physical intensity pathways for more homogeneous sectors. With chemicals, that's difficult because it's so heterogeneous. And so we don't have a single physical intensity pathway for ammonia or methanol at this point. The second pillar is to institutionalize the adoption of targets. And so we have a target setting manual, which is sort of a how-to for C-suite to set and implement and achieve their targets. And the third is this call to action, which we launched back in 2015. And if you click the next slide, you'll see that at this point now we're actually breaking through 1,000 companies this week. We're on track to break through this week. And 460 companies with approved targets, including several chemical companies that I'll discuss in detail. So as I said, this is a voluntary initiative. And so what happens is companies and financial institutions come to the initiative and they submit a target to the initiative. And what the initiative really adds here is a consistent and transparent set of criteria and a validation process. So the next slide shows some of the high-level criteria. So the first is that it covers all of the company's emissions, both in terms of scope 1 and 2 emissions and all the 7 greenhouse gases that are required, so not just carbon or methane, for example. The second is that it's 5 to 15 years from the date of announcement. And the logic there is that there were many companies and other groups that were happy to talk about 2050, but that there wasn't much accountability with a 2050 target. And 5 to 15 years floating 10-year window gives more room to maneuver where it's very capital intensive company. But the 5 years is close enough that companies can do something soon. The third high-level criteria is that the level of ambition of the target is at least well below 2 degrees compatible, and so that's consistent with the Paris Agreement. Now we differentiate targets whether they're well below 2 degrees or 1.5 degrees, or for the older targets, which were submitted before 2019, some of those are 2-degree line targets as well. The next slide shows the fourth criteria, which is covering scope 3 emissions. So for those of you who aren't familiar with greenhouse gas accounting, within the greenhouse gas protocol, we divide a company or other entities' emissions into 3 scopes. Scope 1 emissions are from direct combustion or process emissions in the facility or parts owned by the company. Scope 2 emissions are from purchased electricity, heat and steam or cooling. And scope 3 emissions are upstream and downstream emissions. And there are 15 categories of scope 3 emissions, going from purchased goods and services to use of sold products to financed emissions. And what the criteria says here is that A, the company has to quantify their scope 3 emissions, and B, they need to actually set a target for their scope 3 emissions if it's greater than 40% of aggregate scope 1, 2, and 3 emissions. And I'd say this is the signal achievement of the Science-Based Targets Initiative to get companies to assess their value chain emissions and actually take responsibility for them where they have significant scope 3 emissions. And this is naturally the largest challenge for chemical companies as well, given their complex supply chains and also sort of uncertain use, especially end-of-life disposal issues as well around recycling. And then finally, the fifth sort of high-level criteria here is that companies need to publicly report their greenhouse gas emissions inventory on an annual basis after they've had their target published. And the logic here is that sunshine is the best disinfectant, that this is a way to hold the companies to their target. The SBT initiative doesn't actually do any MRV or tracking of these company targets presently. We're planning to explore adding that capability in the future, but it is a role that is fulfilled by other stakeholder groups in the broader ecosystem. So there are advocacy groups and NGOs and other entities that tend to be tracking the companies in particular sectors fairly closely, and these data are useful for them to be able to assess their performance and ambition. The next slide goes into the project that we launched earlier this year. Chemical companies are obviously important for the broader energy system and for global emissions. Not only do chemical products end up in pretty much every other sector, but also, there's not the same saturation effect with chemicals that we've seen in other heavy industrial sectors, such as steel and cement. It seems that so far people just can't get enough chemicals in their lives. So it's an important sector, and the chemical companies have expressed interest in this, but there's been a lack of clear sector-specific methods. And so we were fortunate to have the US chemical company 3M step up to provide funding for this particular scoping project. The next slide gives an overview of the 23 companies that have publicly committed to setting science-based targets. And you can see that they're from all over the world, and they're also from different parts of the chemical sector in terms of specialty chemicals, pharmaceuticals, and high-value chemicals. And we're starting to get some interest from some fertilizer manufacturers as well. The companies in bold are the ones with targets that have gone through our target review process and met all of the criteria and now have public emission reduction targets that we call science-based targets. They all cover their scope 3 emissions as well. The reason that in this slide Bayer has an asterisk next to it is that they classified themselves as a pharmaceutical and healthcare company when they submitted their target to the initiative. And that's sort of the company's prerogative for the initiative, is to decide which of their business lines is most relevant for this particular target setting exercise. The next slide gives more information about the approved targets and the company's types of targets in terms of the methods that they've used for their scope 1 and 2 and scope 3 targets. So you can see there's a broad range. For those first three, Novozymes, Ecolab, and Bayer, they have scope 1 and 2 targets, which are commensurate with a 1.5 degrees Celsius stabilization pathway for this century. That's the highest level of ambition that we presently include in the Science-Based Targets Initiative. And you can see those scope 1 and 2 targets are absolute. So it means that they have an emissions inventory in their base year, and they're reducing it by at least, let's say 4.5% per year over their target period. They also all have scope 3 targets, and you can see there's more flexibility around the scope 3 targets than there is for the scope 1 and 2 targets. And that's simply because the data and supply chain structure of companies really varies in terms of whether they have large purchase goods and services related emissions, or use of sold product emissions, or other categories. And so we provide some flexibility there. And basically the 4 types of targets that we allow there are absolute reduction of emissions. So that's what Novozymes did with their scope 3 target. And they also included an additional renewable energy target, which is supplemental to their SBT. But we also allow supplier engagement targets. So that's what Ecolab did here. And the idea is that they purchase a lot of inputs, and the way for them to reduce their value chain emissions is by getting their suppliers to set their own science-based target. And so that's another type of target that we include. We also allow for physical intensity targets and economic intensity targets, which here are labeled GEVA, greenhouse gas emissions per value added. So this is just sort of a snapshot of where things are now. I think that there's a need to have more research in this space, given the rapid growth of chemical sector and the need for chemical sector abatement actions to achieve any climate stabilization this century. And so this is an overview. And then just finally, I'll wrap up so we can have discussion and Q&A. We, as part of the scoping project, have run a survey this summer. And this is a summary of some of the results. You can see we got about 35 participants in the survey. And by far, the scope 3 categories where they identified the most need for additional resources and research is purchased goods and services. So that's obvious when it's a sort of brand or consumer-facing company, they often, only really have clarity in their first couple tiers of suppliers. But for a lot of these companies, it does go up to 5 tiers to a chemical company that's providing the inputs, for example, for the clothing manufacturers. But also the use of sold products and end of life for these chemical products is a huge area that needs additional research. There's a big debate around circular economy and recycling of chemicals. And we have some companies that have made some suggestions here, but I think eceee is a forum where there are many of you who are working in this space. And so I just highlight these as areas that could definitely benefit from some of your attention and thoughts. And with that, I think the next slide is just the thanks and the URL for the project website if you'd like more information or to sign up for our stakeholder list. So very quick high-level overview, and I'll pass it back to you, Rod. Thanks.
Thanks, Nate. We've got about 10 minutes left, so this is all. Jens, I think you have a question.
Yes, just a quick question. The problem with science-based targets is not that it's a great idea, but that it usually requires sector-based transformation paths and some kind of realistic view of what can be achieved by which decade with which solutions. Is there such a roadmap that has been commonly agreed upon?
For the chemical sector, you mean?
Yes.
Yeah. So thanks for the question. There are roadmaps that have been developed for the German and Dutch chemical sector because both of those countries have active and well-resourced chemical industry associations. And those do include net zero pathways by 2050. There's similar thinking with the AAC, but that's very political there. And so I'd say the thing about Science-Based Targets Initiative is that there are 2 basic approaches of the companies. One is where you have companies that have a clear investment plan and they have sort of a widget approach of exactly which measures they can take to reduce emissions to a given level. And they use that as the basis of their target. That's sort of group A, let's call them the Teutonic group or some similar name. Then there's group B, which is saying, well, we're not really sure what's going to happen. Technologies are coming up really quickly. We have a range of investment opportunities and growth opportunities and fluctuating demand. We want a demand that is sort of a target that's a North Star target, which sort of helps us to orient our decisions in the future. And at this point, we have no idea how we're going to get that. And the SBT initiative allows both those types of companies to participate with the idea that these targets, again, they're company level. The company has to report once they've set the target, if they're meeting it. Some will fail, of course, but hopefully they will all meet their targets. And what really happens with this type of platform where you have companies setting targets is that they really strongly influence their peers. So with the chemical sector in particular, I presented to the International Chemical Company Association, ICA, in Brussels 3 years ago now. And, the big companies were all there and they all said, yes, this is very interesting. We're aware of this. Yes, thank you for your presentation. And then nothing, stonewalling. And then we had 2 Japanese companies, Sekisui and Sumitomo Chemicals, submit targets. And as you know, there's no pathway now because the IEA lacks the data for a physical intensity pathway. It's too heterogeneous. It's very hard to do a specific pathway for a chemical sector. So they did the global pathway. They said, we're doing absolute reductions in line with what's needed globally by 2050. And we're going to have targets that accord by that, and we're still going to grow. Meanwhile, so as soon as they set targets, then a bunch of other European and other chemical companies piled in. There's a peer pressure effect here. And so that's the first effect, is that it really encourages chemical companies, if they're going to claim leadership, they have to actually do it and set a target. They can't just talk anymore. They actually have to do something that's transparent and quantitative. The second is that this really tends to warm the cockles of the hearts of policymakers, where they say, oh, I can see now that companies in my country are setting targets And now I'm more emboldened to actually provide them some policy support and not be concerned about destroying the economy, because my own companies are doing this voluntarily. So it has a good, that's part of our theory of change with this initiative, is that it catalyzes action not only among the companies, but it also helps to nudge the policymakers along. The caveat is that it's very much of a leadership initiative. And so it's really focused on this edge of the normal distribution, and it pulls along sort of the middle, but those laggards, they're not going to be covered by SBTs ever. And so you really need a regulatory or other framework for that end of the spectrum. But for this end of the spectrum, it really helps to structure where things are going, because otherwise you just have a bunch of loose talk and inconsistent actions and sort of no idea what's actually happening. So, but I'm happy to chat more. Thanks for the question, Jens.
You mentioned that 23 companies have committed to SBTs. But before, at the beginning, I wasn't really following, you mentioned that there's 1,000 companies, or almost 1,000, that did what? I'm not quite sure.
Thanks, Rod. So the 23 companies are the companies that have classified themselves as chemical companies. The 1,000 companies includes, you know, like Daimler and Volkswagen and, numerous companies from all over the world in various sectors. So the 23 is just pulling out the chemical sector companies.
Oh, I see. Okay, so that was.
Yeah.
And but these other, whether it's Daimler, they have also made SBT commitments.
Indeed.
In their sector.
Yeah. So well, there's two numbers here that are relevant. So there's the 1,000, which is including sort of the big picture of committed, and then within that group is the companies that have actually submitted a target to the SBT initiative. So they have 2 years to do that once they commit, and they've had it approved. So that's 470 now.
Okay.
And that is so I focused on those two groups within the chemical sector here, but that's much broader. It includes steel companies, cement companies, Heidelberg Cement, for example, service companies, apparel and footwear. You know, actually our largest sector is food and beverage companies.
Okay. Okay.
But it's all over the map.
One more question just popped up for you. Which technical barriers do you think should be targeted to promote the circular economy in the chemical industry? Is there a crucial for this waste treatment sector in it?
Yeah, I mean, thank you for the question. And, you know, I was trying to get at that with the end of life category of emissions. It's category 12 in the greenhouse gas protocol, scope 3 accounting. And it definitely needs more work in terms of quantifying the emissions associated with end of life. Most, you know, here in Europe, a lot of companies just burn the chemicals products, the plastic, at the end of life. But there are a lot of growing programs around recycling. This, for anyone who's been in the chemical sector for a long time, for decades, which I have not, but I know people who have, has come before, where there were big pushes in recycling, for example, in the US in the 80s. And now, you know, you have these blue bins all over the US where whenever the piece of plastic has some kind of recycling symbol, people don't look at the number in the middle. That's too detailed. You know, they just throw it into the blue bin. And as a result, there's just a huge intermingling of plastic, and they will select out the, you know, like the white plastic jugs and then burn everything else or bury it. And so there's a huge need for research in that space. And it's definitely one of the technical barriers. It's an area where a lot of the companies have targets, but it's really hard to elaborate and quantify them. And we're working with companies on this, but there's a need for more objective academic research as well.
This panel is about, or this section is on increasing demand for financial services. How much is these SBTs, I'll ask the others as well, how much is everything you're doing leading to increased demand for financial services? This is what we're all about. Yeah?
So I didn't realize that's the name of this panel, because I actually, in addition to leading the SBT initiative's chemical sector project, I'm also leading our financial sector project, which is all about developing a framework for financial institutions to set targets for their investment and lending portfolios. And we have separately about 60 financial institutions that have publicly committed to setting science-based targets. We've held them in abeyance because we didn't have this framework done for assessing the scope 3 emissions associated to their investment and lending portfolios, but we're actually publishing that framework on October 1st. I want to leave space for the other panelists, but I'm happy to talk more about anyone who's interested in this.
Well, I don't know, we've got 2 minutes left. Does anybody else want to come in on this about what you're doing, how much that is actually changing financial services. Thomas, Jens, Elsa?
I mean, happy to comment quickly on this. So cooling as a service is one of the programs that we are working on, but really what we are doing here is developing financial mechanisms to accelerate investments in energy efficiency and renewable energy. And in the end, what we see is that many commercial banks or other development banks have a lot of green funding available, but are really looking for projects to invest in. And what's happening is that there's no demand or not sufficient demand for that funding. And this is related this means that it's not a question of availability of financing, but really of risks and perceptions. So it's really interesting to see that very often when we design these mechanisms, it's not at all about making sure there's available green funding, but more how to redistribute the risks between the actors to unlock that investment.
Okay.
And in many
Elsa,
ways,
I'll give you 30 seconds. What's your view? You're on mute? Okay, Jens, for you first.
Yeah, I might add, in my opinion, on my experience, there's enough investors for green technologies, but they do not know how to place it, which projects are actually worth it to invest to. So any kind of data that provides that, any kind of classification systems, guidelines, frameworks, does the job. There's enough money. It cannot be placed actually at the moment. There's more money to be placed than it is placed at the moment, in my opinion.
Okay, I just got a message from Elsa that, sorry, I almost can't hear anything. So I think we're going to have to close up. I mean, Elsa is in Paris. I'll have to meet her privately, and talk to her about this.
I would just echo Jens's and Thomas's points here. And I think, yeah, there's a huge explosion in ESG investing. And again, there's sort of a profusion of green bonds and other activities. And so as with the chemical sector targets, what we're trying to do with SBTs for financial institutions is really standardize this, make it transparent and robust. So we're taking a very physical intensity based approach where there are links, and then also an engagement based approach. So I think, yeah, there's a lot happening in the financing space for sure.
Okay, well, I would like to thank all of you. This is our last session for panel 5, and I think it was one of the best. I mean, it was excellent, and there's just so much to do. And it's actually quite encouraging to see all of this work that's going on scope 3 and some of these programs like we have for cooling as a service. And so we've got our work cut out for us, because we've got even more challenging targets. And I think even this week, the president of the commission is going to be even coming out with stronger targets for us for 2040 and 2050. So I would like to thank, on behalf of eceee, I would like to thank all of you, and hope to see you again next time. Thank you.